my name is Guang, 12 years old, primary 6 from Qifa Primary School. Welcome back to another lesson for physical chemistry. For this lesson on physical chemistry, we'll be continuing to learn for the Maxwell-Boltzmann distribution. So for this lesson of the Maxwell-Boltzmann, so for the last lesson on the Maxwell-Boltzmann distribution, we've used the Maxwell-Boltzmann function to solve two questions for the argon. Well, for this lesson, we'll have to connect with some of our previous lessons. So first we have FV. So two things I need to mention is that I'm going to straight away just jump to both the spherical coordinates, and it's going to be three-dimensional. So it is 4 pi v square root m over 2 pi kb t cubed. Then after that times e to the power of negative m v square over 2 kbt. So over here, that's what we learned from previous lessons. Then from the lesson before last lesson, we need to know like what the most probable speed, the average speed, and the root mean square speed are. So for the lesson before the previous lesson, we have known that the most probable speed, and you write it as VMP, is square root 2 kbt over m. Then after that, for the average speed, it is 3 kbt over 8 kbt, over pi m. Then after that, for the root mean square, it is VRMS is square root 3 kbt over m. So if you want to know the solutions for these three parts, you can go back to the lesson before the previous lesson and learn how these three were shown. So over here for this part, now we have known about these. I'm just going to roughly tell you about what they mean. So for this part, the V is definitely the speed, while the kV is the Boltzmann constant, the T is temperature, and the unit is most definitely in Kelvin. Then that's pretty much all for this part, and math for each particle. Okay. So over here for this part, now that I said about the temperature need to be in Kelvin, and it means that over here for this question where the temperature is in degrees Celsius, it needs to be here. It needs to be converted into Kelvin. Okay, later I'll show you. So for this part, if you want a visual representation for this, it's like, so this is FV and this is V. So over here, if I'm going to draw the graph, it's going to be something like this. Okay, so it just drags over here. So the VMP is like this. So for this part, it's like it's at the top part, which is the highest point is the most probable speed, and then the average speed, yes, it is literally what it says, the average speed. So it's somewhere like over here or something, V with the line above, so average speed. And then for the root mean square, it is the smallest one, which is somewhere like over here, VRMS. So if you are wondering how can I be so certain the fact that which one is smallest and which one is largest, well, you can just check previous videos and all. Okay, so this you can just look at this again. So now over here for this question, we'll be having both. We'll need to solve all three of these, right? So for this part, for part A, what we'll have is that, so the most probable speed, before that we need to be certain about a few things. So the first one, okay, so over here we've learned from previous lessons that KB over M is basically R over MR, right? The molar mass and then the universal constant for ideal gas, right? And so over here, if you're wondering what R is, so R is So R is 8.314. While for the molar mass over here, as you can see, nitrogen gas is N2. So what is N? So N is basically 14 grams, right? So 14 grams over here. This is for the nitrogen. So over here for this part, you have to times 2, who's for nitrogen gas. Okay, so you get 28 grams. But we need to use the SI unit. So for the SI unit, it will become 0.028 kg. And now for this part, we need to also know the temperature. So temperature, which is 25 degrees Celsius, it has to be converted into Kelvin, which is 25 plus 273.15. Okay, so if you want to convert between Celsius and Kelvin, then you just add 273.15. While if you're talking about Fahrenheit, we're not going to deal with that for this lesson. So what we have is 298.15 Kelvin. Okay, so for this part over here, now that we have gotten these parts, you can do these questions already. So VMP is square root 2 kBT. So over here we can just straight away sub it in. So over here, as I have shown here, it is practically 2 RT over MR, right? So it will be 2 times 8.314. The behind digits you can just ignore it. The same for like those nitrogen and all, because these are just the rough answers. So over here, then after that we will have to times the temperature, which is 298.15. And last but not least, over here at the denominator, it will be 0.028. And now we just use the calculator to solve it. So give me a sec. And it is 420.78. And what is its unit? It is meter per second. So all of these over here, what we're using are all SI units, okay? So yes, the fact that for all of these lessons, the results that we get, we always is converted to the SI unit, like the SI unit for temperature being Kelvin, then after that for mass it is kg and all those, okay? So that is for our first part. And now for the second part, as we continue to convert over here, so if you want to know what we are going to use for pi, we are not going to just straight away type in a pi, because normally we just use 3.14. So now over here for this part, V, the average speed will be 8, so KB over M is RT over pi times MR. So over here, what we'll get is 8 times 8.314 times 298.15 over 3.14 times 0.028. So what we get over here is Okay, so what we get is 474.92 meters per second. So in physics, which is over here also physical chemistry, the units are very important, so you need to always know the units because the unit can change the result a lot. Like if you just change meter to kilometer or centimeter, yeah, there's going to be a lot of change. Well, over here for this part, what we're going to have is the root mean square. What we're going to have is 3 RT, because the KB over M becomes R over T, R over MR, sorry. So what we're going to have here is 3 times 8.314 times 298.15 over 0.028. So now over here, if we calculate it, what we get is 515.35 meters per second. So that is what we get for this lesson. So for this lesson, for this part, there's a few things you need to take note of. The first part is for the nitrogen gas, which is because that over here it is N2. Okay, and it is because that if you just put N and this is just nitrogen, it is not nitrogen gas. Okay. Then after that, over here for this part, that's mainly the thing, and for the others, that's like how we gather the solution for these parts. You can check previous lessons, and so these three are the answers that we get. And as you can see over here, these are the answers. Okay. Alright, so that'll be all for this lesson. Last but not least, thank you for your watching.